This video is for Trigonometry Math 112, and this is a follow-up assignment for section 3.2. And so I'm just going to go over the last 6 even problems from section 3.2 that we haven't talked about yet. All right, let's see here. So, problem 14. We've got sine of 2x equals 2 times the tangent minus the cotangent over tangent squared minus cotangent squared. Well, let's see. For starters, over here, I would rewrite this as 2 sine x cosine x, your basic double angle sine identity. Over here, I'm kind of torn. The numerator here says to me we should write those in terms of sines and cosines, right? This is sine over cosine, this one's cosine over sine. These have their own identities involving the secant and the cosecant. I'm not sure that that's going to be helpful. Maybe it will be, maybe it won't be. Let's see here. Well, I'm going to write everything in terms of sines and cosines. All right, and then we'll take it from there. So we're going to have 2, and then this will be sine x over cosine x minus cosine x over sine x. In the denominator, it'll be sine squared over cosine squared minus cosine squared over sine squared. All right, so let's see here. Up here, I'm going to need to make common denominators. So this will get multiplied. The common denominator is going to be sine x times cosine x. So this one gets multiplied by cosine over cosine. That one gets multiplied by sine over sine. And so what do we get out of this then? Let's see here. So this will be 2, and then sine squared x minus cosine squared x over sine x cosine x. Okay. Let's see. So if I'm going to do the same thing in the denominator, this one needs to get multiplied by sine squared over sine squared, and this one by cosine squared over cosine squared. And so then in the denominator, it'll be sine to the 4th x minus cosine to the 4th x over sine squared cosine squared. Okay. Well, I'm not seeing the end point to this just yet, but we'll see what happens. So I'm going to pull the 2 out, okay, and just put it out in front of everything. And then I'll have this, the numerator, sine squared minus cosine squared over sine x cosine x. And then we'll multiply by the reciprocal in the denominator. Okay, so now I'm seeing where this is headed. So for 1, each of these will cancel out one of these. So this sine will cancel out one of these. This cosine will cancel out one of those. This thing is a difference of squares. This is sine squared plus cosine squared times sine squared minus cosine squared. So that this now will cancel with this, and this one's equal to 1. And there is 2 sine x cosine x, which is where we were headed. So for this is probably one of the trickier things right here, is to factor that into a difference of squares, and making these common denominators is pretty tricky. So yeah, that problem is, I think, a little bit more difficult than some of the other ones. Maybe there's another way to approach it that I'm not seeing. Not sure what that would be. But in any event, we got that one done. So let's take a look at problem 16. All right. Problem 16. Let's see. We've got the tangent of 2x equal to 2 over cotangent x minus tangent x. Now, I don't know if there's a standard identity for tangent 2x. I seem to remember that there is one, but in any event, what I normally do here is just write this as sine 2x over cosine 2x, and then we can use those identities, cosine squared minus sine squared. Now don't fall into the trap of trying to cancel here. You can't cancel these because of that minus sign, okay? Over here, let's see, we've got a 2. Well, it looks like, you know, we're headed here. We've already got the 2 in there, so hopefully we'll get the rest of this as we work through it. So this is cosine x over sine x minus sine x over cosine x. So we're going to make a common denominator down here, and then we're going to flip that over and multiply by the reciprocal. So let's go ahead, make our common denominator of sine x cosine x. And then this one gets multiplied by cosine over cosine. Yeah. So this is now 2 on the top, cosine squared minus sine squared over sine x cosine x. Yeah, and we're almost done. You can see the pieces. We've got all 3 pieces that we need, the 2, the cosine squared minus sine squared, and the sine x cosine x. So this will be 2 times sine x cosine x over cosine squared x minus sine squared x. And there we go. We're done. Okay. That one was a lot more straightforward. Okay. 18, I think, is going to end up being very similar to this one. You've got the sum of a sine of a tangent and a cotangent. I would rewrite those in terms of sines and cosines. Let's see here. Where are we? Problem 18. So tangent x plus cotangent x is 2 times the cosecant of 2x. So this is 2 over sine of 2x. So those 2's cancel, so this is 1 over sine x cosine x. So that's where we're headed over on the other side. And this, like I said, this is going to be very, very similar to what we were just doing. We're going to write this in terms of sines and cosines. And we just went through this process of creating a common denominator for these. And here it is, right here. See, that's where we're headed, is that common denominator of sine x times cosine x. So this one gets multiplied by cosine over cosine. That one gets multiplied by sine over sine. And we come out of this with sine squared x cosine squared x over sine x cosine x. And then, of course, replace that sine squared plus cosine squared with a 1, and we're done. Okay, let's see here. Problem 20. What do we have? Sine of 2x. So that's 2 sine x cosine x. Over on the other side, 2 tangent x over 1 plus tangent squared x. Okay? So this one I recognize right away, right? We've got an identity for that one. Also, whenever you see tangent squared, secant squared, sine squared, cosine squared, those all have identities for them. And this one, 1 plus tangent squared, that should be the secant. 1 plus tangent squared, secant squared. Yes. And that's always helpful, I found, turning the denominator from two terms into a single term, right? Because I just mentioned earlier that you can't do any canceling, like especially here, you can't cancel this tangent with the tangent squared because of this addition right here. You can only cancel things that are factors, okay? And a single term is a factor, all right? So if we had something going on here, we could cancel it. So let's see, but in any event, once we write this in terms of sines and cosines, I think it'll be a little bit easier to work with. So let's put the 2 off to the side, call the numerator sine over cosine. The denominator is going to be 1 over cosine squared. So then, sine x over cosine x times the reciprocal, cosine squared over 1. That will cancel out one of those. And there we go, 2 sine x cosine x. That one was relatively straightforward. But you can see, you know, these variety of strategies. You know, writing things in terms of sines and cosines is sometimes helpful. Using these Pythagorean identities, recognizing those, that's also really helpful. And making common denominators also comes in handy in a lot of situations. I didn't use that in this one, but you can see the 3 previous ones, we did have to make a common denominator. Okay, let's see here. Problem 22. Let's see what we've got. Secant squared x times the cosine of 2x on one side, and secant squared minus 2 tangent squared. Huh. All right. Well, let's see here. Well, one thing, notice that this doesn't have any adding and subtracting in it, whereas this one does. So there's a couple things that we could do here. One thing I'm noticing is that this first term is secant squared. So if we had like a parentheses here that was 1 minus something and we distributed this into the parentheses, right, then that would give us a secant squared here. And there is an identity for cosine of 2x that starts out 1 minus, right? And it ends, I believe it ends 2 sine squared x. So I think I'm going to make that my first step here, which is to replace that cosine 2x with 1 minus 2 sine squared x. Then multiply through, that'll be secant minus 2 secant squared sine squared. And then the secant is 1 over cosine squared. And so there's our tangent squared. Secant squared x minus 2 tangent squared x. And it's the same on the other side. Okay? Let's see here. All right, problem 24. Let's see what we get here. 2 tangent x minus sine 2x over 2 sine squared x. And we want to show that that's equal to the tangent, which I suspect it's going to be helpful to write that in terms of sines and cosines. Okay, let's see here. Well, we've got one identity here, minus 2 sine x cosine x 2 sine squared x. Let's see here. Well, what I would do is I would factor out a 2 up on top and then cancel it with that 2. So now we've just got tangent x minus sine x cosine x divided by sine squared x. Well, let's see. In this one, I would split this fraction rather than write the tangent in terms of sines and cosines. I think I'm going to end up doing that anyway. But I just see some canceling here that would be helpful. I'm not sure how this is going to work out, but that's what I'm going to do. I'm going to split this fraction tan x over sine squared x minus sine x cosine x over sine squared x. See, here I can't cancel those signs because of this subtraction. But when I separate the problem, now I don't have the subtraction in this piece of the fraction anymore, so I can cancel that with one of these, and this will be cosine x over sine x. This one here, let's see, I would write this as sine x over cosine x over sine squared. So that's going to be what? That'll cancel out one of those. So I'm going to have 1 over sine x cosine x minus cosine x over sine x. Well, let's make a common denominator then of sine x cosine x. So this will get multiplied by cosine over cosine, and I'll have 1 minus cosine squared on top and sine x cosine x on the bottom. Again, you can't cancel these because of that subtraction, but what you can do, and we're going from here up to there, what you can do is replace that 1 minus cosine squared with a sine squared. Now we've just got a single term in the numerator. This cancels out one of these, and there we go, we're done. That one was kind of messy. I'm not sure if there's a better way to approach this one. Like I said, the only thing I could think to do differently is to rewrite this as sine over cosine first, and then make a common denominator in the numerator, but I'm not sure whether that would work out any better or not. All right, let's see. So that's problem 24. Let's see what else we've got here. Oh, that was the last one. As I was erasing, I was thinking to myself, 24, I think that's the last one. Okay, all right, so like I said, this is a follow-up assignment for section 3.2, so it's a little bit shorter than the first one. So we'll have another quiz to go with this, and then we'll move on. The other videos this week, we'll cover sections 3.3 and 3.4, solving trigonometric equations. We will use some identities in solving those equations, so we'll finish those up this week, and then we'll move on into chapter 4. And I will also get the second project ready to hand out. Let's see here. It'll be sometime next week when I get that handed out. As always, if you have any questions, please let me know.